Fact 51. Some stars spin hundreds of times faster than our sun. Most stars rotate slowly. Our own sun takes between 25 and 35 days to complete a single full rotation, depending on the latitude you measure from, but some stars spin with extraordinary, almost violent speed, completing a full rotation in just a few hours. These rapid rotators are often young and massive, their equators visibly bulging outward from the centrifugal force of their own spinning. Some reach such extreme velocities that they fling material off their surfaces entirely, forming glowing disks of expelled gas that ring them like halos of their own making. Their internal structures are fundamentally different from calmer stars. Their evolutionary paths altered. Their lives often shorter and more dramatic. They burn with an intensity that slower stars never know, spinning like sirens in the dark, brief, and utterly alone in their speed. Fact 52. Milky Way is tilted relative to our own solar system. When you look up on a clear night and trace the soft, hazy band of the Milky Way arcing across the sky, you might notice that it doesn't follow the same path as the sun and planets. That is because it doesn't. The galactic plane, the broad, flat disk in which most of the galaxy's stars reside, is tilted at roughly 60 degrees relative to the ecliptic, the flat plane traced by our solar system as it orbits the sun. This tilt is why the Milky Way rises at an angle across the sky, why it shifts its position with the seasons, why it appears higher in some months and lower in others. We are part of the galaxy, but our own small solar system sits at a slight angle to its greater disk, a small tilted boat, drifting through a far larger spinning sea of stars. Fact 53. In the galactic halo, there are white dwarfs older than the Milky Way's own disk. White dwarfs are the cooling remnants of stars that have exhausted their nuclear fuel, the dense, slowly fading cores left behind after a star like our sun reaches the end of its long life. Most white dwarfs we encounter formed relatively recently on cosmic timescales, but astronomers have found white dwarfs drifting in the outer halo, ancient beyond almost anything else in the galaxy, older than the thin disk itself, formed during the earliest era of star formation, when the Milky Way was still assembling its shape from a loose, collapsing cloud of gas and dark matter. They have been cooling for billions upon billions of years. Fading, dimming, slowly surrendering the last of their warmth to the cold of space. They are not dramatic, not violent, not bright, but they carry within them deeper history than almost anything else we know. The disk may be bright and beautiful, but the halo remembers further back. Fact 50. 4. The most distant stars in the Milky Way orbit tens of thousands of light years beyond the familiar spiral arms. Far out beyond the bright disk, beyond the stellar streams, beyond even the outer reaches of the known halo, there are stars. Faint, sparse, moving in enormous, slow orbits that take billions of years to complete a single loop around the galactic center. Many were likely captured from smaller galaxies in ancient mergers, torn from their original homes and flung outward into the Milky Way's vast gravitational influence, now drifting in the outermost reaches of the galaxy like distant sentinels, marking the true edge of our cosmic home. They are extraordinarily difficult to find. barely visible even to our most powerful telescopes, but they matter because they help define the galaxy's true size, its true shape, the full reach of its gravitational embrace. The Milky Way is not just what we see in the night sky. It extends deep into the dark, shaped and defined by wanderers. At its very edge, fact 55, the Milky Way's disk wobbles as it spins. The great disk of our galaxy does not rotate in a perfect, stable plane. It wobbles gently, slowly, like a spinning plate that has been nudged ever so slightly off balance. This warp and wobble is most visible in the outer regions of the disk, where one side curves upward and the other dips softly downward. And the wobble itself rotates, moving slowly around the galaxy like a vast, unhurried wave passing through billions of stars. It may be caused by the gravitational influence of the Magellanic clouds tugging at the disk's edges, or by interactions with unseen clumps of dark matter, or by asymmetries deep within the galaxy's own structure. From Earth, we cannot feel it. We have no sensation of this immense, slow swaying motion carrying us through space. But from a great distance, the Milky Way is not a pristine, still spiral. It is a breathing, undulating, gently swaying sheet of stars, curving softly as it turns. Fact 56. The galaxy exerts tidal forces that slowly unravel star clusters and stellar streams. Just as the moon's gravity raises tides on Earth, the immense uneven mass of the Milky Way exerts tidal forces on everything within it. Star clusters feel it. Satellite galaxies feel it. Even globular clusters drifting high above the galactic plane feel the galaxy's gentle but relentless gravitational pull. Over time, these tidal forces stretch and distort. They draw out long trails of stars from clusters that pass too close to the dense inner galaxy. They slowly peel stars away from their companions. They unravel small galaxies into ribbons of light that wrap around the disk, many of the faint stellar streams mapped across the sky are the remnants of exactly these encounters. Clusters in the process of being slowly pulled apart. Galaxies quietly dissolving into streams. The Milky Way does not break these structures suddenly or violently. It unravels them patiently, gently, strand by strand. Across millions of years. Fact 57. We still do not know the true mass of the Milky Way. It seems like something we should have measured by now. Our own galaxy, the home of our sun, the structure we have studied for centuries. And yet, its total mass remains genuinely uncertain. The stars and gas we can observe make up only a fraction of the whole. The vast majority of the galaxy's mass lies in the dark matter halo, invisible, undetectable except through its gravitational effects on everything around it. Estimates vary considerably. Some calculations suggest the Milky Way weighs close to 1 trillion times the mass of our Sun. Others place it significantly higher. The uncertainty comes from trying to measure how fast stars orbit at the galaxy's outermost edges, a task made enormously difficult by limited data and the invisible, shifting influence of dark matter. The Milky Way is our home, and we still do not know how heavy it is. Some mysteries live right where we are. Fact 58. The Milky Way may actually be more massive than the Andromeda Galaxy. For a long time, astronomers assumed that Andromeda was the dominant galaxy of the local group, slightly larger, slightly brighter, and therefore heavier. But recent measurements have complicated that picture. Studies suggest that the Milky Way's dark matter halo may be broader and denser than previously believed, extending further into space, containing more mass than earlier estimates accounted for. If those measurements hold, our galaxy may actually outweigh Andromeda. Despite its more modest visible appearance, this matters not only as a P&T than as a point of cosmic pride, but because when the two galaxies eventually merge billions of years from now, their relative masses will fundamentally shape how that collision unfolds. Which black hole dominates? Which structure survives? What the resulting galaxy ultimately becomes? Milky Way may look quiet and gentle dot, but beneath its soft spiral arms, it may carry more weight than we ever imagined. Fact 59. The Magellanic Clouds may be visiting the Milky Way. For the very first time, the Large and Small Magellanic Clouds are two bright satellite galaxies visible from the southern hemisphere, glowing softly in the night sky like detached fragments of the Milky Way itself for a long time. Astronomers assumed they had been orbiting our galaxy for billions of years, loyal, long-standing companions in the dark, but new measurements of their velocity and trajectory through space have raised a surprising possibility. They may be newcomers, captured only recently. In cosmic terms, this may be their first close pass near the Milky Way. Not long-standing companions at all, but distant wanderers only now falling under our galaxy's gravitational influence for the first time. Their arrival has already stirred the outer disk, warped the galaxy's edges, left traces in the structure of the halo dot. The Milky Way is responding to a new gravitational presence dot in the sky, so full of what seems ancient and permanent, is full of first encounters. Fact 60. Trailing behind the Magellanic Clouds is a vast ribbon of stolen gas stretching across the southern sky. It is called the Magellanic Stream, and it is one of the largest structures associated with our galaxy, a ribbon of hydrogen gas, hundreds of thousands of light years long, pulled away from the Magellanic Clouds by tidal forces as the two dwarf galaxies passed close to one another. And close to the Milky Way. It is invisible in ordinary light, but in radio wavelengths, it reveals itself as a long sweeping arc across the sky, a trailing whisper of motion and slow, gradual loss. This stream may one day contribute to new star formation within the Milky Way, settling into the disk and providing fresh material for new suns to ignite, or it may simply drift into the halo like a thread of memory stretching gently between galaxies, a long, quiet record of a journey that is still unfolding. And somewhere between the wobbling disk and the stolen ribbon of gas trailing through the southern sky, I hope your breathing has grown slower. Your thoughts a little looser. The edges of the day a little softer. You are resting on a planet that wobbles, inside a solar system that bobs, within a galaxy that sways and tilts and breathes with invisible magnetism. And all of it is simply turning slowly, quietly, without asking anything of you at all. Asterisk. Fact 61. Some clouds of gas in the Milky Way orbit in polar directions. Not everything in our galaxy follows the neat, orderly plane of the disk. Some clouds of gas, and even some stars, move in highly inclined orbits, tilted far above and below the galaxy's main structure, passing over the poles of the galactic disk like comets arcing high above the plane of a solar system. These polar orbits are almost certainly the result of ancient mergers, when dwarf galaxies or stray clouds were captured by the Milky Way at odd angles. They were not immediately absorbed into the disk's rotation. Instead, they continued along their original tilted paths, looping above and below the galaxy on their own independent trajectories. They have been doing so ever since. These misaligned orbits are quiet records of disruption, visible reminders that the galaxy is not a closed, perfectly ordered system, but an evolving structure, shaped by the unpredictable and beautifully chaotic flow of cosmic history. Fact 62 across the Milky Way. There are enormous spherical shells of gas marking where the galaxy once burned brightest. In several regions of the disk, astronomers have discovered vast hollow bubbles of expanding gas, some spanning hundreds of light-years across. These shells are the remnants of ancient starbursts, episodes when dense clusters of massive stars formed together in rapid succession, lived their brief, brilliant lives, and then exploded one after another in a cascade of supernova. Their combined stellar winds and shock waves carved enormous cavities into the surrounding interstellar medium, blowing gas outward in every direction like a slow, silent breath released from the galaxy's lungs. Over millions of years, the expansion slows, but the shells remain ghostly, hollow, still drifting gently outward, marking the places where the galaxy once blazed with extraordinary stellar birth and death. Fossils of cosmic fireworks still echoing quietly in the cold. Fact 63. In the densest regions of the Milky Way, stars occasionally collide. Space is almost incomprehensibly vast, and stars are almost incomprehensibly small relative to the distances between them. In most of the galaxy, the chance of two stars actually meeting is effectively zero across any human timescale. But in the densest regions, the tightly packed cores of globular clusters, where hundreds of thousands of stars are crammed into a sphere only a few dozen light-years across, the odds change. Stars pass close enough to gravitationally interact, to disturb each other's orbits, and very occasionally to collide. When they do, the result can be extraordinary: a sudden flare of released energy, the merging of two stellar cores into a single larger sun, or the formation of what astronomers call a blue straggler star, a star that appears mysteriously younger and bluer than all its neighbors, as though it somehow cheated time. These collisions are rare. But they happen. In the galaxy's most crowded neighborhoods, even the stars are not always safe from one another. Fact 64. Binary stars can be torn apart by the tidal forces of the galaxy. Many stars do not travel alone. They orbit each other. Two suns bound together in a gravitational embrace, circling one another across thousands or millions of years in a quiet, intimate dance. But even this bond can be broken if a binary system drifts too close to the supermassive black hole at the galaxy's center, or passes through the dense, gravitationally turbulent core of a star cluster. The tidal forces acting on the pair can become unequal enough to disrupt their shared orbit entirely. One star is captured or slowed. The other is flung outward with tremendous velocity, sometimes fast enough to escape the galaxy completely. These stellar separations happen silently, in places we rarely observe, a quiet, irreversible tearing of ancient partnerships by gravity's indifferent hand. Two stars that spent billions of years in each other's company parted in a moment, one falling inward, one flying forever outward into the dark. Fact 65. Some stars reach escape velocity and leave the Milky Way entirely, never to return. These are hypervelocity stars, and they are among the most solitary objects in the known universe. Most are thought to be ejected by close encounters with the supermassive black hole at the galaxy's center. Others are launched by the explosive asymmetry of a supernova in a binary system. One star dying so suddenly and violently that its companion is released like a stone from a sling dot once free. They travel outward through the galactic halo, past the outermost stars, past the edge of the disk, out into the vast, dark intergalactic space between galaxies. Tiny points of light moving alone through a universe that offers no destination carry the galaxy's memory outward with them. Chemical fingerprints of the stars they once orbited near, traces of the environments that shaped them, solitary pilgrims in the great dark between galaxies, drifting forever. Fact 66. Not all stars within the Milky Way were born here. Some arrived from elsewhere during the many mergers and collisions that built our galaxy over billions of years. Stars from absorbed dwarf galaxies were incorporated into the Milky Way's halo and disk. Captured intergalactic wanderers flung into our gravitational reach from distant regions of the local group. These cosmic immigrants often move on unusual orbits, tilted, elongated, far from the familiar patterns of stars. Born within our own galaxy, they can sometimes be identified by their chemical compositions or by the particular way they move through space. Stars that don't quite fit the local patterns, that carry traces of environments very different from our own. Like immigrants arriving in a new city, they bring with them stories from other places, other histories, other skies. The Milky Way is not a sealed original structure. It is a living mosaic. Slowly and continuously stitched together by time and motion and the long reach of gravity. Fact 67. Above and below the Milky Way's disk, gas rises and falls in a continuous, quiet cycle. It is called the galactic fountain. When clusters of massive stars explode as supernova, and when powerful stellar winds blow outward from the hottest young stars, enormous quantities of heated gas are ejected upward from the disk, rising high into the halo above and below the galactic plane. There, far from the warmth and density of the disk, the gas cools. Condenses. And begins to fall gently back downward over millions of years. It rains softly back onto the disk, carrying with it the heavy elements forged and scattered by the stars below, mixing with fresh gas, stirring the interstellar medium, helping regulate the conditions for new star formation. This cycle has been running for billions of years. The galaxy does not simply spin. It circulates. It exhales upward into the halo and inhales again. As the gas returns, a slow, deep, cosmic breath, keeping the disk alive across immense spans of time. the Milky Way glows fiercely in X-rays. From collapsed stars and hungry black holes to human eyes, the galaxy appears serene, a soft river of light crossing the night sky. But in X-ray wavelengths, it tells a very different story. X-rays pour from the galactic core, from the twisted magnetic environments around neutron stars, from the edges of black holes wherein falling matter is heated to millions of degrees in the final moments before it disappears. Binary systems where a white dwarf or neutron star slowly siphons material from a companion star. Heat that stolen gas to extraordinary temperatures, causing it to glow brilliantly in high energy light before it finally falls inward. Hot gas in the halo itself emits faint X-rays, revealing the galaxy's larger skeleton. Its hidden bones, telescopes like Chandra and XM Newton, have painted a portrait of the galaxy that our eyes will never see directly. Not a tranquil spiral, but a realm of extreme temperatures, compact stellar remnants, and hidden radiation burning quietly behind the beauty we can see. Asterisks scattered throughout the Milky Way. Pulsars tick like the most precise clocks in the universe. When a massive star collapses at the end of its life, it sometimes leaves behind a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. Some of these neutron stars are left spinning rapidly, with beams of radio waves sweeping outward from their magnetic poles like the beam of a lighthouse rotating in the dark. These are pulsars, and some rotate hundreds of times per second, with a regularity so extraordinary, so consistent, that they rival the best atomic clocks ever built by human hands. Astronomers use them as cosmic timekeepers, tracking their precise signals to measure distances across the galaxy, to test the fundamental laws of gravity, and to search for the faint ripples of gravitational waves passing through space. Across the Milky Way, pulsars blink quietly in the dark, remnants of death, but also beacons of astonishing, almost impossible, order, ticking steadily. Not for minutes or hours or years, but for entire epochs. In the silence between stars. Much of the Milky Way's true structure is invisible in ordinary light, but radio waves can reveal it. Vast regions of the galaxy are hidden from optical telescopes, obscured by dust, too faint or too cold to glow in visible wavelengths. Entire spiral arms, star-forming regions, the precise shape of the disk's warp. All of it concealed behind the limitations of human vision, but radio waves slip through dust clouds as though they are not there at all. They trace the cold hydrogen gas threading through the spiral arms. They reveal the shape of the galactic magnetic field. They highlight the distinctive signals of pulsars and supernova remnants. They echo from distant quasars far beyond the edges of our galaxy, using vast arrays of radio telescopes spread across continents. Astronomers have mapped the Milky Way's spiral arms with precision that visible light could never achieve, measured the warp of the outer disk, discovered star-forming regions, cloaked entirely in darkness, where light is blocked. Radio lets us see. The galaxy speaks in a language our ears cannot hear, but one that science has, slowly, patiently, learned to translate into shape and shadow. 70 facts now. And somewhere between the pulsars, ticking in the silence and the gas rising and falling in its ancient galactic breath. I hope you are close. close to that soft, quiet place where thoughts become images and images dissolve into warmth. The galaxy is breathing around you. Stars are being born in cold, dark clouds far from here. Ancient white dwarfs are cooling in the outer halo, and somewhere a pulsar is ticking, steady, patient, precise. Like a heartbeat in the dark. Our sun was almost certainly born in a stellar cluster. Stars rarely form alone. They are born in groups, dozens, hundreds, sometimes thousands of stars igniting together from the same vast collapsing cloud of gas and dust, siblings of a shared origin, all carrying within them the same chemical fingerprints of the cloud that gave them life. Our sun was almost certainly one of these, long ago. Perhaps 4.5 billion years ago, it shared its earliest existence with hundreds of companion stars, all born together in the same stellar nursery, warming the same gas cloud with their newborn light. But over time, the cluster began to drift apart. Gravitational tides from the Milky Way, passing stars nudging orbits. The slow, inevitable dispersal that claims almost every open cluster eventually. The sun's siblings scattered, carried away on different paths through the galaxy. Now lost among the 100 billion other stars of the Milky Way. Somewhere out there, the sun has family. Wandering, unrecognized, shining quietly. In the dark, astronomers are searching for the sun's lost siblings, scattered across the galaxy. Though the sun's birth cluster dissolved billions of years ago, the search for its siblings has begun, using vast astronomical surveys like the Gaia space mission. Researchers are mapping the positions, motions, and chemical compositions of billions of stars across the Milky Way, looking for stars that share the sun's age, its velocity through space, and its particular chemical fingerprint, the unique blend of elements baked into it at the moment of its birth. Few candidates have already emerged, stars that may have formed from the same collapsing cloud, that spent their earliest existence in the same nursery as our own sun, that once shared a sky with the young Earth. They are scattered now across light years of space. But the traces of their shared origin remain. Written in chemistry. Waiting to be read. Our place in this galaxy. May not be quite as solitary as it seems. The Milky Way's structure changes. Across billions of years. Galaxies may appear timeless when we look at them, fixed, permanent, eternal arrangements of light and gravity, but they are always evolving. Spiral arms shift their positions, bars form and gradually dissolve. Gas flows inward along the disk and outward through the halo. Stars are born and grow old and die, leaving behind a slowly changing stellar population that makes the galaxy a subtly different place with every passing epoch. Even the shape of the Milky Way's disk, warped and rippling and gently lopsided, is slowly altering, responding to the gravitational influence of nearby dwarf galaxies, to the slow redistribution of dark matter, to internal dynamics that play out across timescales no civilization has ever lived long enough to observe directly. The Milky Way of today. Is not the one that existed when the dinosaurs walked the Earth. And the one that will exist when the sun finally grows cold. Will be something different still. Its beauty lies not in permanence. But in quiet, patient, endless transformation. Gravitational waves ripple through the Milky Way from distant cosmic collisions. All across the universe, massive objects are colliding, black holes spiraling together across millions of years, before finally merging in a single cataclysmic moment. Neutron stars crashing together in brilliant kilinovae. Entire galaxies folding slowly into one another. Each of these events sends ripples outward through the fabric of space-time itself. Gravitational waves. Distortion so subtle that they stretch and compress the distance between objects by less than the width of a single atomic nucleus as they pass. And yet, they are real. They are measurable. And some of them pass through the Milky Way and through the Earth and through you. Right now, observatories like LIGO and Virgo have already captured the signals of several such events. New experiments are being designed to detect the background hum of gravitational waves filling the cosmos from countless mergers happening simultaneously across the universe. Even as you rest, space itself is shifting, not enough to feel, but enough to tell us that somewhere far away, the universe is changing. Some stars in the Milky Way travel on elongated, steeply tilted paths. Not all stars move in neat circular orbits around the galactic center. Some follow long, stretched ellipses, looping high above the disk and far below it, tilted at steep angles to the main plane of the galaxy, tracing paths that carry them through very different environments on each orbit, from the sparse outer halo down through the dense inner disk and back again across hundreds of millions of years. These stars almost certainly arrived from elsewhere, relics of dwarf galaxies long since absorbed by the Milky Way, survivors of ancient gravitational upheavals that flung them onto unusual trajectories they have followed ever since. Their orbits are clues. Three-dimensional maps of the galaxy's chaotic and turbulent past. By tracing their motion with precision, astronomers can reconstruct the invisible architecture of the Milky Way's mass and memory. These stars drift like quiet messengers from disrupted systems, tilted, stretched, but still bound, still here. The Milky Way is subtly, but unmistakably, lopsided. Though diagrams and illustrations almost always show our galaxy as a beautifully symmetric spiral, the real Milky Way is not perfectly balanced. One side of the disk is measurably thicker than the other. The spiral arms are uneven in brightness and length and curvature. Some are more prominent, others fragmentary and faint, trailing off into loose collections of stars rather than sweeping cleanly around the disk. The stellar halo is slightly off-center. Even the distribution of star-forming regions across the galaxy is not uniform. These asymmetries likely arise from the gravitational influence of the Magellanic Clouds, tugging at the disk's edges, from the uneven distribution of dark matter clumps in the halo, from the accumulated effects of past mergers that left their marks on the galaxy's structure. Billions of years ago, the Milky Way is not a perfect pinwheel. It is a living structure, marked by tugs and twists, like a spinning dancer whose skirt has been caught gently by the wind. Its beauty lies precisely in that irregularity, a graceful imbalance, sculpted slowly by time. Certain stars pulse in brightness, and astronomers use them to measure the galaxy. Across the Milky Way, there are stars that breathe. Not literally, but they expand and contract in remarkably regular cycles, growing brighter as they swell outward, dimming as they pull back inward, pulsing with the slow, luminous heartbeat of stars in a particular phase of their lives. These are variable stars, and certain types, known as Cepheid variables and RR Lyrae stars, have a beautifully precise relationship between the speed of their pulsing and their true luminosity. Measure how long a star takes to complete one pulse, and you can calculate exactly how bright it truly is. Compare that true brightness to how bright it appears from Earth. And you can calculate exactly how far away it is. These pulsing stars serve as cosmic yardsticks, scattered through the spiral arms and the halo, blinking their slow, patient signals across light years of space, helping us measure the shape and scale of a galaxy. Too vast to grasp any other way. Lights that measure the dark. The Gaia space mission is revolutionizing everything we thought we knew about the Milky Way, launched by the European Space Agency. The Gaia spacecraft is doing something no instrument has ever done before. It is measuring the precise positions, the exact motions, and the detailed brightness of over 2 billion individual stars across the Milky Way, constructing a three-dimensional map of the galaxy with a level of accuracy and completeness that was simply impossible just a decade ago. With each new release of its data, the picture of our galaxy sharpens dramatically. Gaia has revealed stellar streams from galaxies the Milky Way consumed billions of years ago. It has mapped the subtle warp of the outer disk with extraordinary precision. It has traced the Sun's own orbit through space in finer detail than ever before. It has uncovered ancient merger events written in the motions of stars that no longer remember their true origins. It is turning a hazy, uncertain smear of light into a sharp, living, breathing map, a quiet revolution unfolding among the stars. The night sky is brightest in the direction of the galactic center. If you have ever looked toward the constellation Sagittarius on a dark summer night, you have looked toward the heart of the Milky Way. In that direction lies the greatest concentration of stars in the sky, the central bulge, the galactic bar, the supermassive black hole sleeping at the very core. Billions upon billions of stars packed more densely than anywhere else in the disk. We cannot see the very center in visible light. Dense clouds of interstellar dust block our view entirely. The galactic core is hidden from human eyes behind curtains of darkness, but even so, the region glows, crowded, luminous, filled with the overlapping light of countless stars too numerous and too distant to resolve individually. We orbit far from this center. In a quiet outer suburb of the galactic disk. But when we look inward on a clear dark night, we glimpse the crowded, ancient, radiant city. At the galaxy's heart, because we live inside the Milky Way. We will never see it from the outside. This is perhaps the most quietly humbling truth about our home galaxy. Every image you have ever seen of the Milky Way as a whole, every sweeping spiral of light and color, is light. Planetary systems form throughout the entire Milky Way. Planets are not rare. They are not special exceptions scattered sparsely through the galaxy like lucky accidents. They are a natural, almost inevitable consequence of how stars are born. As a new star ignites at the center of a collapsing gas cloud, the leftover material surrounding it does not simply disappear. It flattens into a rotating disk of gas and dust. And within that disk, over millions of years, particles begin to collide, to stick together, to gather mass, to grow. First into pebbles, then boulders, then worlds across the Milky Way. Planetary systems are extraordinarily common. Some harbor vast gas giants with dozens of moons. Others are compact systems of rocky planets orbiting close to dim red stars. Some may resemble our own solar system closely. Others defy every expectation we have formed from studying our own cosmic neighborhood. The galaxy is not simply full of stars, it is full of systems, solar families. Each one unique, each one balanced, each one carrying within it the quiet possibility of something we have not yet imagined. Earth orbits near a special location in the galaxy called the co-rotation radius in the Milky Way. The spiral arms do not rotate at the same speed as individual stars. They are patterns moving through the disk at their own independent pace. Stars drift into them, pass through them, and drift out the other side, but at one particular distance from the galactic center, something special happens. The average orbital speed of stars matches the rotational speed of the spiral arms themselves. This is called the co-rotation radius, and our Sun orbits remarkably close to this boundary. The significance of this is profound. Stars near the co-rotation radius spend less time crossing through the dense, turbulent, radiation-rich environments of the spiral arms. They avoid frequent encounters with the clusters of massive stars and supernovae that concentrate within those arms. They exist in a kind of gentle orbital resonance with the galaxy's own patterns. We live in a more stable neighborhood than most, shielded not by walls or distance, but by resonance. By the quiet coincidence of matching speeds in a vast and otherwise turbulent disk. As the Sun orbits the Milky Way, it bobs gently up and down through the galactic plane. The Sun does not follow a perfectly flat path around the galaxy. Instead, it oscillates, drifting slowly above the galactic plane, then back downward through it, then below, then rising again, like a cork floating on a slow ocean swell, rising and falling over a cycle of roughly 60 to 80 million years. This vertical motion is driven by the gravitational pull of the galaxy's mass, concentrated in the disk, tugging the solar system back toward the plane whenever it drifts too far above or below. Some researchers have wondered whether this gentle bobbing motion might influence conditions on Earth, whether the solar system's periodic crossings of the denser regions of the disk could affect the flux of cosmic rays reaching our planet, or the rate at which comets are disturbed from the outer solar system. Evidence is not yet clear, but the motion itself is real. Even on its long, steady journey around the galaxy, the Sun is not gliding in a straight line. It is swaying softly, slowly through space. Many stars are born in clusters, but almost all clusters eventually dissolve. When stars form together from the same collapsing cloud, they begin their lives in close company, bound to one another by their shared gravity, moving together through the galaxy like a small traveling city of light. Some clusters survive for billions of years. The tightly packed globular clusters of the halo are ancient examples of stellar communities that have held together across almost the entire history of the universe. But most open clusters, the looser groupings born in the spiral arms, are far less enduring. Gravitational tides from the Milky Way's mass pull at them constantly. Close encounters with giant molecular clouds disturb the orbits of their stars. Internal dynamics slowly push members apart, one by one. Stars peel away, drifting off into the general star field of the galaxy. Until the cluster fades entirely, dissolving not in drama or violence, but in the quiet, gradual, patient dispersal of things that were never meant to hold together forever, even. Our sun was once part of such a cluster, its siblings now scattered, dimmed, lost in the haze of distance and time. Deep within the galaxy's central bar, there may be a smaller bar hidden inside. At the heart of the Milky Way lies the large central bar of stars we have already visited, that elongated bridge of light crossing the core, rotating slowly, shaping the inner spiral arms, funneling material toward the supermassive black hole at the galaxy's very center. But astronomers examining the motions of stars and gas in the innermost regions of the galaxy have found something unexpected: hints of another structure, a smaller bar, tilted at a different angle to the outer one, rotating independently, nested within the larger bar like a secret kept at the heart of a secret. It is extraordinarily difficult to observe directly, hidden behind layers of dust and the overwhelming brightness of the galactic core, but its gravitational fingerprints appear in the motion of nearby stars and gas clouds. Influencing, shaping, quietly redirecting the flow of material toward the center. The heart of the Milky Way is not one simple structure. It is a layered, shifting, labyrinthine arrangement of light and gravity and motion. Complex beyond anything a single image could capture. When clusters of massive stars explode together, they carve chimneys of hot gas through the galactic disk. When multiple supernovae detonate in the same region of the galaxy in close succession, their combined energy does something remarkable. It punches upward. The enormous cavities carved by each individual explosion merge into vast superbubbles, pockets of superheated gas too energetic to be contained within the disk. They push upward through the galactic plane like rising columns of heat, breaking through the surface of the disk, venting their energy, their gas, their magnetic fields, upward into the halo. Above, these are galactic chimneys, channels, through which the disk breathes. Outward. Through which the energy of dying stars escapes into the vast space above and below the galaxy. They redistribute heavy elements, regulate the pressure of the interstellar medium, shape the structure of the halo itself. The galaxy in this way does not simply spin in silence. It exhales upward through towering invisible columns, carrying the breath of its stars out into the dark. Some stars in the Milky Way were enriched by the collision of neutron stars. We have spoken already of kilinovae, those brief, blinding, extraordinarily violent collisions between two neutron stars, spiraling together across millions of years before finally merging. In those collisions, heavy elements are forged in quantities that no other process in the universe can match. Gold, platinum, iridium, uranium, blasted outward into the surrounding interstellar medium. Mixed into the gas clouds drifting through the galaxy. Incorporated into the next generation of stars forming from those clouds. Some of those stars still burn today. Carrying within their atmospheres the unmistakable chemical signatures of those ancient collisions, enriched in elements that could only have been born in the merging of two of the densest objects the universe has ever created. They are not simply stars, they are living records, burning archives of cataclysms that happened billions of years ago, in events so brief and so brilliant that they outshone entire galaxies for just a few days. The Milky Way's core may once have blazed as a quasar. Today, the center of our galaxy is quiet. Sagittarius A* sleeps, occasionally stirring as a small cloud of gas drifts too close and flares briefly in X-rays, but mostly still, mostly dark. But there is growing evidence that this was not always the case. The enormous Fermi bubble stretching above and below the galactic center, traces of high-energy light reflected in surrounding gas clouds, the particular structure of the inner halo, all of it hints at a past, far more dramatic than the present, a time when the supermassive black hole at the galaxy's heart was actively consuming vast quantities of infalling gas, when it blazed with the violent brilliance of a quasar, one of the most luminous objects in the universe, outshining the entire combined light of every star in the galaxy. If the Milky Way once burned like that, it would have looked almost unrecognizable. A spiral galaxy wrapped around a blinding, violent, radiant heart of light. That time has passed. The fire has quieted, but the echoes remain drifting silently above the galaxy we know, whispering of something ancient that once burned. The galaxy holds far more than we will ever directly observe, even with every telescope we have ever built, even with every wavelength of light we have learned to detect, even with every survey and map and catalog assembled across centuries of astronomy. We have seen only a fraction of what the Milky Way truly contains. Light is blocked by dust. Motion is hidden in the silence of dark matter. Entire populations of faint stars lie below the threshold of our instruments. Rogue planets drift unseen in their billions. Ancient stellar streams are too diffused to detect against the background of the sky. The Milky Way is not just what we see. It is what we suspect. What we infer from the motion of things we cannot directly observe. What we long to understand, but have not yet found the tools to reach. It holds ancient light that has been traveling for billions of years toward eyes that do not yet X. We know dark matter exists, but we do not know what it is. This is one of the most extraordinary admissions in all of modern science. The substance that makes up the majority of the Milky Way's mass, the invisible scaffolding holding the entire galaxy together, the thing without which every star you have ever seen would drift apart into the void, is completely unknown. It does not emit light. It does not absorb light. It does not interact with ordinary matter in any way we have yet been able to detect directly. It passes through everything, through stars, through planets, through you, without leaving a single measurable trace. And yet it is there. Its gravitational influence is unmistakable. It holds the galaxy's outer stars in their orbits when nothing else could explain their speed. It shapes the formation of cosmic structures across the entire universe. We know it exists because of what it does, not because of what it is. It is the greatest mystery the Milky Way carries within. It silent, invisible, everywhere and still. After decades of searching, completely beyond our reach, most of the Milky Way's mass lies outside the disk we can see. When you look at the Milky Way, at the pale river of light crossing the night sky, you are looking at the galaxy's most visible feature, its stars, its gas, its dust, but that glowing disk, for all its beauty and scale, represents only a fraction of the Milky Way's total mass. The vast majority lies elsewhere. In the enormous dark matter halo that surrounds the disk in every direction, extending far beyond the furthest stars, reaching out into intergalactic space to distances we are still trying to measure. This halo is sparsely populated with ancient stars and globular clusters, but its true bulk is invisible, undetectable except through the gentle distortion it imprints on everything around it. When we picture the Milky Way as a spiral of light, we are picturing only the surface. The glowing skin of something far deeper. Far larger. Far heavier. Than the beauty we can see. Spiral arms are shaped by waves of density moving through the disk. We have touched on this before, but it is worth returning to because it is one of the most quietly beautiful truths about the galaxy. The spiral arms of the Milky Way are not rivers of fixed stars flowing around the disk. They are waves, patterns of slightly higher density moving slowly through the galactic disk like ripples moving across the surface of a still pond. As gas and dust encounter these waves, they are compressed. Stars ignite. The arms light up with brilliant young suns blazing, blue and white. Those stars eventually drift out of the wave, new ones form behind them. The pattern is self-sustaining, self-renewing. Always in motion. From a great distance it appears like permanent structure, like solid sweeping arms carved into the galaxy, but from within it is simply a pattern, a beautiful, temporary, continuously renewed illusion of form. Held together by nothing more than constant gravity and time. Stars are born from the coldest places in the galaxy. It seems counterintuitive that light and heat and the blazing nuclear fire of a new sun should begin in cold, but that is exactly what happens. In the darkest, coldest, most isolated regions of the Milky Way, where temperatures drop to just a few degrees above absolute zero, where no light penetrates and no warmth reaches, gravity quietly begins its work. Vast clouds of molecular hydrogen drift through the disk, cold and dark and still, and within them, in regions slightly denser than the rest, gravity slowly draws material together, collapsing inward, heating as it falls, spinning faster as it contracts, until, eventually, the pressure and temperature at the center reach the threshold where hydrogen nuclei begin to fuse and a star is born. From the coldest shadows come the brightest lights, spun gently into being by nothing more than the patient, inevitable, quiet force of gravity. The oldest known star in the Milky Way may be nearly as old as the universe itself. High above the galactic plane, drifting through the outer halo on a long, slow orbit, there is a star that astronomers have studied with particular reverence. It contains almost no heavy elements whatsoever, just the simplest chemistry the universe has ever known. Which means it formed extraordinarily early, before generations of supernova had time to enrich the cosmos with heavier elements, before the Milky Way had fully assembled its disk, before most of the structures we recognize as our galaxy had even begun to take shape. This star is believed to be more than 13 billion years old. The universe itself is only 13.8 billion years old. This star has been burning for nearly all of it. It glows quietly now with a soft red light, low in mass, unhurried, patient beyond any measure of patience. We can truly comprehend it is not just a star. It is a living relic, time capsule from the universe's very earliest dawn. Still here, still burning, after almost everything else that existed when it was born is long gone. The Milky Way contains an almost incomprehensible number of worlds. We have spoken of planets throughout this journey, but let the full scale of it settle for a moment. The Milky Way contains somewhere between 100 billion and 400 billion stars. Astronomers now believe that on average, each star hosts at least one planet, possibly more. That means there are likely hundreds of billions of worlds in this galaxy alone. Rocky worlds, ocean worlds, gas giants with moons larger than Earth, ice worlds drifting in the cold outer reaches of distant solar systems, planets orbiting two stars simultaneously, worlds with skies of entirely different colors than ours, and among those hundreds of billions of worlds, some portion orbit within the habitable zones of their stars. With liquid water, with stable climates, with the basic chemistry that life requires. We do not yet know if any of them harbor life, but the conditions for it exist in extraordinary abundance. The galaxy is not empty. It is full. Overflowing. With possibility. The Milky Way is asymmetric, and that asymmetry gives it character. We are drawn to symmetry, to balance, to the clean perfection of a neat spiral pinwheel turning evenly in space. But the real Milky Way is lopsided, warped, slightly off-center in ways that no simple diagram fully captures. One side of the disk is thicker. The spiral arms are uneven. The stellar halo is not perfectly spherical. The central bar is not quite straight. The outer disk bends upward on one side and downward on the other. These imperfections are not flaws. They are the galaxy's history, made visible. Every asymmetry is a scar, a memory, a trace of something that happened, a merger absorbed, a satellite galaxy consumed, a gravitational encounter that nudged the structure slightly and left a mark that has persisted for billions of years. The Milky Way is lopsided in the way that anything truly alive is lopsided, not despite its history, but because of it. Its beauty lies not in perfection, but in everything it has been through. Interstellar medium is a turbulent, creative, endlessly cycling sea. We have visited it several times on this journey. That thin, invisible, complex mixture of gas and dust and plasma weaving through the space between every star, but perhaps its most extraordinary quality is this. It never truly rests. Material flows into it from dying stars. Supernova compress it into waves of new creation. Stellar winds sculpt it into shapes that drift and change across millions of years. New stars form within it, live their lives, and return their matter to it when they die. The interstellar medium is the galaxy's great recycling system. Nothing is wasted. Nothing is lost. Everything that has ever existed in the Milky Way has passed through it. And everything that will ever exist is waiting within it. It is the quiet connective tissue of the galaxy. The medium through which all things flow, the sea from which stars are born, and to which they always return. The Milky Way has been turning for over 13 billion years. 13 billion years. Before the Earth existed, before the Sun ignited, before the first complex molecules assembled themselves into something capable of wondering about the stars above, the galaxy was already turning, slowly, gathering its spiral shape from the chaotic, formless early universe, absorbing smaller galaxies, building its disk, igniting star after star after star in great sweeping waves of creation, and it will continue turning long after everything we know is gone, after the Sun has expanded into a red giant and consumed the inner planets, after it has collapsed into a quiet white dwarf cooling in the dark, after the Andromeda Galaxy has merged with our own and reshaped everything we recognize as home. The galaxy will still be turning. Different, evolved, changed beyond recognition, but continuous. Unbroken. The same slow rotation that began before the Earth was born, still carrying forward everything that remains. You are here. Inside all of this, not observing it from a distance, not reading about it from the outside, not separated from it by glass or screen or the comfortable illusion that the cosmos is something happening somewhere else. You are inside it. Right now, resting on a rocky planet orbiting a middle-aged star in a quiet spur of a barred spiral galaxy that has been turning for 13 billion years. Iron in your blood was forged in a star that died before the Sun existed. The calcium in your bones was scattered by ancient supernova across light years of space. The oxygen filling your lungs right now was breathed out by dying stars across billions of years before it found its way to you. You are not a visitor to the universe. You are made of it, assembled from its oldest materials, animated by its CH. The Milky Way has been turning for over 13 billion years, 13 billion years, before the Earth existed, before the Sun ignited, before the first complex molecules assembled themselves into something capable of wondering about the stars above. The galaxy was already turning, slowly gathering its spiral shape from the chaotic, formless early universe, absorbing smaller galaxies, building its disk, igniting star after star after star in great sweeping waves of creation, and it will continue turning long after everything we know is gone, after the Sun has expanded into a red giant and consumed the inner planets, after it has collapsed into a quiet white dwarf cooling in the dark, after the Andromeda Galaxy has merged with our own and reshaped everything we recognize as home. The galaxy will still be turning. Different, evolved, changed beyond recognition, but continuous. Unbroken. The same slow rotation that began before the Earth was born, still carrying forward everything that remains. Fact 100 are here. Inside all of this, not observing it from a distance, not reading about it from the outside, not separated from it by glass or screen or the comfortable Illusion that the cosmos is something happening somewhere else. You are inside it. Right now, resting on a rocky planet orbiting a middle-aged star in a quiet spur of a barred spiral galaxy that has been turning for 13 billion years. Iron in your blood was forged in a star that died before the sun existed. The calcium in your bones was scattered by ancient supernova across light years of space. The oxygen filling your lungs right now was breathed out by dying stars across billions of years before it found its way to you. You are not a visitor to the universe. You are made of it, assembled from its oldest materials, animated by its chemistry, sustained by the light of one of its 100 billion stars. And tonight, in the dark, in the stillness, you are resting inside a galaxy that is still turning dots, still creating, still holding you in the quiet gravity of everything it is. A long silence. The ambient tone barely exists now, like the last moment before sleep takes everything. The closing. And now, the stars begin to dim. Behind your thoughts, we have traveled a long way tonight, from the warp of the galaxy's outer disk to the ancient fossilized light of the oldest stars in the halo. From cold dark clouds where new suns are forming right now, to the sleeping giant at the galaxy's heart. From stellar streams left behind by galaxies that no longer exist, to the invisible dark matter holding everything silently together. 100 quiet truths. About the place you call home. And somewhere in between all of those truths, I hope something settled in. You. Something that the busyness of the day sometimes makes it hard to feel. That you are not adrift in a meaningless void. That you are held. By gravity, by chemistry, by the long unbroken chain of stellar generations that had to live and burn and die in exactly the right sequence, across billions of years, to eventually produce the atoms that became you. The galaxy did not make you by accident. It made you the way it makes everything, slowly, patiently, through countless cycles of creation and transformation, fire and cold and time and silence. You are the Milky Way, becoming aware of itself. And tonight, it is resting. So rest with it. Let your breathing slow to the rhythm of something ancient and enormous and completely unhurried. Let the spiral arms turn above you in the dark. Let the stars drift on their long, slow orbits without your help. Let Sagittarius A** sleep at the center of everything. Let the cold molecular clouds hold their breath a little longer. Let the pulsars tick quietly in the silence, and let yourself simply be. Here, warm, breathing, made of stars, floating in the spiral arm of a galaxy that has been turning since long before you arrived and will keep turning long after tonight is nothing more than a memory drifting gently into sleep. Ambient tone fades completely to silence, nothing, just the dark and the stars. And you, good night.